Tim, today's helium spectrum look okay?
As the day ends, another journey of discovery begins.
We want to look at some active galactic nuclei and quasars tonight, and we're going to start off with observations of NGC 1275. Can you put the coordinates in? And I'll go.
Tony Reedhead investigates the most powerful galaxies in the universe. Reedhead will use the 200-inch telescope on Palomar Mountain, one of the world's largest. Tonight he will probe deep into space, exploring the hearts of galaxies.
Science is certainly an adventure. It's a continual voyage of discovery. It seems to me remarkable that we can do experiments here on Earth and then translate this experience to what's going on in a distant star or a distant planet or in a distant galaxy.
The adventure of astronomy unfolds in majestic mystery. Once we thought a galaxy was merely an oasis of billions of stars, floating in quiet serenity. But not all galaxies are so flawlessly elegant. Some have distorted shapes, others ghostly tentacles. Strangest of all are the distant objects that appear as only faint points of light. Quasars look like stars, but are really the centers of the most distant and powerful galaxies. A quasar can outshine 1,000 normal galaxies. To seek the source of this enormous power, astronomers use a different way of seeing. The glare of the visible world conceals the radio universe. A universe detected by radio telescopes, like these at the Very Large Array in New Mexico. The VLA is the most complex radio telescope in the world. Each of these 27 dishes is connected by computer to form a single telescope 20 miles across. The VLA provides a view of the cosmos 5 times more detailed than the optical telescope at Palomar, and it provides a different kind of picture. When the dishes are aimed at a galaxy, detected radio waves form a map, revealing unseen regions shining with radio energy. The location and intensity of the radio waves are coded with colors. Through radio telescopes, astronomers have discovered that some galaxies radiate far more energy as radio waves than as light. One such galaxy astronomers call NGC 1275. 1275 is not a quasar, but it bears a family resemblance. Like a quasar, the galaxy produces most of its energy in a tiny region at its core.
Not really the 10 kiloparsecs, but that's sort of 60 arc minutes.
Tony Reedhead of Caltech is a leader in the study of quasars.
I'm trying to think of the whole scale here. But of course we want to go in a lot deeper to the core of NGC 1275 here.
Reedhead views 1275 as a mini-quasar.
It would take 10 million years to produce that total energy.
He believes the galaxy's energy arises from the same process that powers quasars.
Well, here you're looking at a region in NGC 1275, and the interesting thing is that it has this very bright and compact active region, which is very bright in the radio. Now, if you looked at this object optically, it doesn't seem all that extraordinary. It's a slightly unusual galaxy, but not very unusual. But it turns out that a very small fraction of galaxies which look quite ordinary in the optical, when you look at them in the radio, have extraordinarily high radio emission. They're very energetic objects. So the energy that's pouring out of here in the radio is more than the sum total of all the energy that's coming out from the whole galaxy, all the stars in the optical.
Only one thing seems capable of generating so much energy in so small a space: a giant black hole. Enormous black holes may lurk in the hearts of galaxies. Galaxies were born from great clouds of hydrogen gas, brought together by the hand of gravity. At the very center of the cloud, the gas is squeezed ever more dense. If dense enough, a black hole will form. Feeding on the surrounding gas and stars, the black hole can grow to the size of our solar system, and nothing can escape from it, not even light. The gravity of a supermassive black hole could be the engine that powers quasars. But how does the engine work? How can gravity be the source of such enormous energy? The force of gravity wasn't always so mysterious. Visible light was once the only way to see. But then astronomers found a new window, the universe of radio. Jesse Greenstein was a pioneer in the discovery of quasars. He was an astronomer before black holes were even equations on a chalkboard. It was a different universe, a different time.
I had been interested in astronomy, and I wanted to go on in science. And I got a master's degree at Harvard in 1930, and then all hell had broken loose. I saw people jump out of windows. This was the great bottom, the Depression. My father and grandfather and uncles and so forth beat on me that I ought to be in the family business, that fresh blood would bring back the family fortune. So I tried it for 4 years, and it was a lot of fun in the sense that I hated it. By 1934, I asked my present wife to marry me, and she said yes, but not if I stayed in business. So I gave that up and became a mere fact finder, and I've enjoyed it ever since.
The search for facts led Greenstein to Pasadena, California. Caltech's Palomar telescope had just been built. Optical astronomers were having a heyday, but radio astronomers had barely begun. With only primitive telescopes, they could not identify the sources of the unusual radio waves they were detecting. Their radio pictures lacked detail.